All right, welcome. In this video, we're going to be taking a look at simplifying radicals. This is likely something that you saw in Algebra 1. However, I just want to make sure that we're all on the same page with it moving forward, because otherwise Section 8.1 and really all of Chapter 8 could be a challenge for you guys. So this is really a precursor for Chapter 8. All right, so jumping right into it, let's say that we get this problem, simplify the square root of 50. All right, so when I say radical, remember that radical is just any number that is under this square root sign. So we could read this as radical 50, we could read this as square root of 50. Either way, it's really saying the same exact thing. So first, we want to identify a perfect square that is a factor of the number under the radical. So in this case, we are trying to identify a perfect square that is a factor of 50. Remember, what are some of our perfect squares? I like to run through just some of the lower perfect squares. We know that one of our perfect squares, 2 squared, is 4. We have 3 squared is 9. 4 squared is 16. Unfortunately, none of these numbers are factors of 50. 5 squared is 25. So 25 is a perfect square, and it is a factor of 50. So that's going to be the next number that we're using. Some other perfect squares that we have 36, we have 49. And so you should be pretty familiar with your perfect squares up to about 12 squared, which is 144. All right, past that, I'm not really going to expect that you know your perfect squares too well, so don't worry too much. All right, if there isn't a perfect square that is a factor underneath of the number underneath the radical, then it can't be simplified any further. So for example, if we have the square root of 21 or radical 21, yeah, we might find some of the factors like 7 times 3, but because those are not perfect squares, because they're not any of these numbers along here, okay, we can't simplify radical 21 any further. That's just going to be your answer. All right, so again, we found that 25 is a factor of 50, and that's just 50 is equal to 25 times 2. All right, 50 divided by 2 gives us 25. Perfect, so 50 is equal to 25 times 2. Our second goal, the second thing we need to do once we've identified that factor, is rewrite the number as a product of those factors. So we can take square root of 50 and we can rewrite it as the square root of 25 times 2. All right, so I just took 50, I rewrote it as a product of its factors. Of course, one of those factors must be a perfect square. All right, moving along to our next step, we can then split that fraction up. So we have the square root of 25 times 2. We can actually split that up into 2 different radicals, still multiplying each other. The reason we're allowed to do that is because it's multiplication. For multiplication or division, you're allowed to split it up. For addition and subtraction, you are not. So if you have the square root of a times b, that is equal to the square root of a times the square root of b. If you have the square root of a plus b, that is not equal to the square root of a plus the square root of b. You can't split that up. When it's multiplication or division, yes, that's fine. All right, we'll draw a little smiley face there. That's okay. All right, so we split it up into square root of 25 times the square root of 2. And of course, we know the square root of 25 is just 5. So if we want to rewrite that, well, I had the square root of 25 times 2. I know the square root of 25 is 5. So I get 5 times the square root of 2. Often you won't see it written with this little multiplication symbol right here. Okay, most of the time it's just going to be 5 right next to the radical 2. Again, whenever 2 numbers are written next to each other, like this case, that is implying multiplication, 5 times the square root of 2. Let's run a couple of quick practice problems, and then I will send you on your merry way. All right, so starting off here, we look at square root of 20. We take a look at 20 and we see, okay, well, what are some of its factors? We've got 1 in 20, 2 in 10, 4 in 5. Boom, as soon as I think of that, 4 and 5, well, 4 is a perfect square. So I can rewrite that as the square root of 4 times 5. which is the square root of 4 times the square root of 5, which is just going to be 2 times the square root of 5. So square root of 20 simplified down to 2 square root of 5. For 27, I think of some of its factors. I've got 3 and 9. Boom. I immediately hear 9. I know, okay, 9 is a perfect square, so I'll rewrite this as square root of 9 times 3. Well, that's square root of 9 times the square root of 3. And the square root of 9 is just 3. So I get 3 times the square root of 3. All right, now for this last one, I'm taking a look at 48. I think of some of its factors, 2 and 24. We've got 4 and 12. Boom, as soon as I hear that 4 and 12, I'm going to split this up. Write it as a square root of 4 times 12. That is then 2, that is the square root of 4, which is 2 times square root of 12. All right, again, here, let me just erase that. I skipped a step in there for you guys. I'll make sure I show it all out. So I get square root of 4 times the square root of 12. Well, that's just 2 root 12. However, I'm not actually simplified here. The reason for that is because square root of 12 can actually be simplified further. The square root of 12 is the square root of 4 times 3. So I could write that as 2 times the square root of 4 times the square root of 3. Well, that's 2 times the square root of 3, which is 4 square root of 3. All right, we might have also noticed if we just started right here and we realized, oh, 16 is also a factor of 48. We could have rewritten it as the square root of 16 times 3. So square root of 16 times square root of 3. That's a 16 right there, which would then give us 4 square root of 3. Either way, we are getting to the same exact answer. All right, it's just one way is a little bit quicker. When we can identify the largest perfect square factor that goes into a number, then it's a little bit quicker as we go to simplify the radical. Hope this helped you guys out. I hope that this is kind of like jogging your memory a little bit and you remember doing this previously in Algebra 1. If not, don't worry, we will make sure that you have it down and ready to go for Chapter